Hi, my name is Mark Ellis from Stick and Rudder Studios, and today I want to take you through some of the basic concepts in X-KeyPad 1.5. So here are some of the items we're going to cover. First off, I want to talk with you a little bit about hardware versus virtual devices. And in this particular area, we're going to talk a little bit about the PI Engineering X-Keys keyboards, and then about the virtual devices that you can create within X-KeyPad. What I'm not going to cover is the X-Touch Mini. There is a whole separate tutorial on that that you can watch that'll take you through how to configure everything you want to do on an X-Touch Mini MIDI controller. The next thing I want to do is take you through an introduction to the DataRef tool, and this is a tool that you'll potentially use quite a bit when you're defining your key definitions. And you also will use this tool, and by the way, just in general, the concepts we're going to talk about here, they generally go along with the X-Touch Mini too. So watching this is definitely going to help you if you're just using the X-Touch Mini. And then we're going to talk about the difference between commands and data refs with an X-Plane. And then we're going to walk you through a basic key definition. We'll start off doing a basic key definition on a PI Engineering XK80. And you're going to find that a lot of what you do there, it's going to match perfectly if you were doing it with virtual devices. We'll then talk about how to use a logic data ref and a logic test and what they are, and how they can be used to drive the LED states underneath the keys of an XK80. And then also how you can use those same things to drive the device colors on the keys of a virtual device and the dynamic labels on a virtual device. So once we cover all these topics, you'll have a pretty basic understanding of how things work within X-KeyPad, and then the subsequent tutorials will take you into a much greater depth of how things work. So with that, why don't we jump right into X-Plane and take a look at this DataRef tool. Okay, so the DataRef tool is it's a freeware open source tool that's very easily available. You're going to find if you go to xplane.org that a lot of people use it. The link for where to get it is actually in the user guide, and it's a pretty simple tool to use. Once you install it, you should be able to see it available up here in the plugin manual under DataRef Tool. And what I'm going to do is just go ahead and do a search here. Now, what does this DataRef tool do? It allows you to search for commands and search for data refs. And we're actually going to use this tool to talk a little bit about what the difference between a command and a data ref is. So not only does it let you search for them, but you can actually test the commands out, and you can actually look at what a data ref has in it, and if the data ref is writable, you can manipulate it. So what's the difference between a command and a data ref? A command is an action that you can do within the simulator. An example, toggle the taxi lights on and off, okay? When you go to your joystick settings, your keyboard settings within X-Plane, and you try to map either a joystick button or a keyboard keystroke to something, you are mapping that to a command. It basically means that when I press that button on my joystick or I press that key on my keyboard, I'm going to execute that command and the simulator do whatever that command was meant to do. Okay? Let's take an example of one of those. Let's come up here, and in the search terms, we're going to search for taxi. And over here under this D plus C, we're looking in the search, we're looking for both data refs and commands. I can change it so that I only look for commands. Okay? And you can see with this filter of taxi, there are 3 commands that the DataRef tool is able to find. Turn the taxi lights off, turn the taxi lights on, and toggle. Okay? And I'm just going to come down here and bring up the view with X camera of the switches. We'll zoom in here a little bit so we can actually see them. And there we are. Okay? And if I actually operate the taxi lights here, you'll actually see that the command that's actually turns to yellow. So if I turn it back to on, it goes to on. And you can see that this action in the 3D cockpit is actually using the 2 different commands. But I can also come down here in the DataRef tool and highlight toggle, and I could do an actuate on it. And you can see as I press the actuate button, it's going to actually make that command operate. Same is true if I come over here and I press on. Since it's already on, it's not going to do anything. If I check off, if I check on, it goes on. So that's the concept of a command. And you can even do a search for commands. If you come over here with the DataRef tool and you hit search, as I toggle this back and forth, you're going to see what it's doing is it's showing you the last command that was active. Okay? And that's what the DataRef tool does. Now, let's take a look at the concept of a DataRef. That was a command. Let's look at a DataRef. So let's come over here and do just data only. We'll take off change, and we're going to look for taxi. Now you'll notice that there's a whole bunch of DataRefs here that represent DataRefs or pieces of data that have got the word taxi in them. And as we operate this light, you'll see that some of them change. So you can see here that the cockpit electrical taxi light on went from a 0 to a 1 when I turned it on. Also, the SIM cockpit 2 switches taxi light on went from a 0 to a 1. Let's just do that again so you can see those changing. Okay? Now, we use commands in X-KeyPad that when you press on a key, you want that key press to do something. In that case, you're going to map that key press to a command. We typically use the DataRefs to drive the state of an LED, or in the case of a virtual device, the labels, on the virtual device. So in that case, we actually need the data to actually do a logic test on that and drive it. In some cases, sometimes these DataRefs are writable, and you can actually write to them and change what's going on. Let me give you an example. If I come down here to this taxi light on switches, if I do an edit on this, if I change it from a 1 to a 0, you'll notice that the switch changed. If I come in here and I edit it and I put it back to a 1. So sometimes you can actually use the DataRef to not only drive the LED, but in X-KeyPad, if with the ability to manipulate the DataRef, you can change the state of things. Now, I want to caution you, not everything has a writable DataRef, and you're going to find lots of combinations of these things within a payware plane. Some payware planes don't have commands behind the 3D cockpit operations. All they have is DataRefs, and they're editable and you can manipulate them. On rare occasions, sometimes you'll find there's only a command behind a particular switch and there is no DataRef behind it, which makes it, frankly, sometimes a little difficult to drive the LED on X-KeyPad. Generally what I found is most things in a 3D cockpit are going to have a DataRef behind it that represents the state of that particular 3D cockpit control. It may or it may not be writable, okay? And in most cases, you will typically find a command that'll actuate that case. And if you can't find a command, generally the DataRef behind it will be writable so that you can manipulate it in that way, shape, or form. Okay? So that's a little bit about the DataRef tool. It allows you to search for commands and try them. It'll also do things like allow you to manipulate 3D cockpit operations and then see what commands actually got activated. And the DataRef tool will also let you look for DataRefs and see what their values are, and if they are writable, it'll allow you to change them. All right, so it's a very, very useful tool to have. And that's a little bit about commands and DataRefs. Now, the next thing I'd like to do is show you what's the difference between a hardware device and a virtual device. So what you see here is a PI Engineering XK80. And I've actually got this one all configured so that you're seeing that it's all lit up. Now, what these hardware devices are, they're keyboards. You can get them in either an 80 key. They have a 60 key one. There's a 40 key one that's kind of elongated. If you take a look at the website, you'll see the various dimensions you've got. They're really very nice units. The keycaps on these, you can actually pop the keycap off and you can put a label underneath them. I typically label mine with vellum paper that I print out with a laser printer. And then underneath each key is a red LED and a blue LED that you can operate independently. And the red LED and the blue LED can either be off, on, or it could be flashing. So what this is going to give you is if you put both the red and the blue on, you get kind of a purplish hue to the key. You could have just the blue LED on, just the red LED on, none of them on, or you can even have them so that they're flashing on and off. Okay? The touch on the devices is really nice. They're very well built, very high quality. As a matter of fact, they're actually used often in industrial applications, so they're really built to last. The only thing I would say about them that's a bit of a disadvantage is that the key labels, once you label them, they're kind of static. You're not going to be ripping up all of your keycaps and changing the labels underneath them for different aircraft that you're flying. So you generally have to do a layout that uses the most common keys that you're going to find in pretty much any aircraft that you're going to fly. But they feel great, and when you're flying with them, because they're a real keyboard and a real nice touch on the key, it feels like it might be like a real button you might have in an aircraft. Okay, and you can drive them very dynamically. As you can see here, I turn the COM2 monitoring on and off. I could do
transponder on mode A.
Change the transponder mode, and you could see that what X-KeyPad's able to do is drive the lighting underneath the keys based upon the state of data refs or variables within the simulator. Okay, so that's an example of a physical PI engineering hardware device. Great devices, just that they've got that limitation where the labeling on them is not dynamic if you start switching planes around that you're flying. Now let's take a look at a virtual device. Okay, so this is a virtual device. And a virtual device is basically, it's a pop-up window that X-KeyPad creates. And you can, they're basically a grid of keys. The keys are always in a square format. You can't make them elongate or whatever, but they're square. But you can define them in pretty much any layout you want. This one I actually have it modeled so it kind of matches an X-Key80. But you could have them where there's more rows than columns, more columns than rows. You've got quite a bit of flexibility in how you lay them out. And they actually have the ability to perfectly emulate a hardware device. If you actually happen to have done a configuration for a hardware a device, the virtual device can emulate it. If it's emulating a virtual device, the only colors you have available for the background of the keys is going to be either a red or a blue, because that's all the hardware devices have underneath them. But if you're using it as a full-blown virtual device, you have an incredible amount of control over what goes in these little boxes, these keys. You can control the background color. You can control the font color. You can control the font. You can control the labeling. And all of these things can be extremely dynamic. Let me give an example on this transponder.
Transponder on.
You'll notice here that not only did I change the color of the transponder key, but the label changed, based upon the state.
Transponder altitude mode.
Based upon the state of the transponder. So virtual devices have got a lot of flexibility to them. And what people typically will do is they'll create these virtual devices, and then they drag them and they'll put them on a touchscreen monitor, which is attached to your flight sim computer, but it's not running. It doesn't have the flight sim on it. It's just a separate touchscreen monitor that you have off to the side. And since a touchscreen monitor can emulate a mouse, basically you could touch these keys and they'll do all the things that you would do with a hardware device. You can even use a piece of software called Duet Display, and there's actually a freeware version of something similar to Duet Display. I can't remember the name of it. But what that will do is it'll turn either your iPad or an Android tablet into a touch monitor. So you can even drag these virtual device screens over onto a Duet Display monitor and have all this stuff being shown on a on a tablet. Now the only challenge I have with the tablet is relatively a small form factor, so it's hard to jam a lot of keys on there and still have enough space to be able to touch it. Certainly something like an X-Key80 and 80 key layout will work fine, but if you start doing things like 128 keys or things like that, they just get a little bit, the touch area is too small for that format. For my flying, I like to run my stuff with a 22-inch touch monitor, and they work really fantastic. And you can intermix using hardware keyboards with your virtual devices. The other thing that's nice about virtual devices is you can define a number of units with them, up to 8. And if you have another unit, it will show up across here in this top bar, and you can very easily switch, to different units. So you can get thousands of keys available to you, using virtual devices. They're really pretty handy. The downside to them is a touch monitor. It doesn't have the same tactile feel to it that a real keyboard does. They work great, but it's like it's similar to touching the touch screen on your GPS in your car, is the best way I can kind of describe it. It works like that, but very powerful. Okay, so with that, why don't we go in and take a look at how we would define a basic key. And what I'm going to do is I'm going to walk you through how we do this with the editor. First, I'm going to do it on the hardware device, primarily because that's the most limited. And a lot of what you would do on the hardware device, it just works magically, in the virtual device. And then we'll switch over to the virtual device and show the more of the capabilities of what you could do with it. Okay, so let's take a look at that. Okay, so we have the Cessna 172 G1000 here. And what I did is I just opened up the X-KeyPad configuration editor. Let me actually close it for you and show you how you get at it. You come to the plugins menu, you go to X-KeyPad, and you're going to bring up the X-KeyPad configuration editor. In this window, you either can work it in here, or you can also pop it out if you want, using these little squares, just like you would like the Garmin 430. Pop it out, put it on another monitor if you think that makes it a little bit easier to work with. Okay, and in here, you have the choice of picking the unit that you're working with. As you remember correctly, virtual devices can have up to 8 units. You can also put 8 physical PI engineering keyboards on your system if you want. And those units are numbered 0 through 7. So we're going to start working with unit number 0. The next thing you got is the key that you're working with. Now, in the hardware devices, the way the keys are labeled is they start at the very first column, and they're labeled 0, 1, 2, 3, 4, 5, 6, 7, and then they go to 8, 9, 10, 11, 12, 13, 14, 15. That's the way they're labeled or numbered. Same with a virtual device. They always start at the upper leftmost column, and you go down that column row by row, and then back up to the next column and continue to count down again. And then each device also has the ability to have a shift function, which is sort of like just a normal keyboard. If you shift it, you get a whole nother set of keys just on sort of like a different layer. And we can actually take a look at how that works. Okay. On each key, you have the ability to, you've got a number of tabs up here, your keys, your global formulas, which we'll talk about in another tutorial. You've got your units. You can actually give them a name if you wish. You can specify whether they're a hardware unit or not. Virtual device layouts, we're going to get to that in a minute. And then you've got an ability to have just your configuration comments. It's just free-form text that you can put in that describes, what this configuration does and how it works. On the key tab, you have a number of labels here. You have a logic data ref. You got primary LEDs. These are the red and blue LEDs that are under the covers of a hardware device. They also work on virtual devices, just using red and blue LEDs. You've got the commands that would be associated with the key. Here's a numeric data ref. We're going to talk about that in another tutorial. And if it's a virtual device, you've got things like font colors, and key labels that you can define. Hardware devices, you're not going to have these. As a matter of fact, if I come over here to the unit setup and I mark this unit as being a hardware unit, if I come back over here to keys, you're going to notice that those tabs went away because you can't define key labels and fonts on a hardware device. They are kind of what they are. Okay. All right. So let's come on over here to the commands. This is the very first thing that we want to do. So the first thing I want to do is identify which key is the taxi key. And I actually have an X-K80 here that's already labeled. So we know that this key over here is the taxi light key. If I have this option up here, see this checkbox that says activity right here? If I have that checked, if I press a key on the device, it's going to automatically select that key and tell me what key number it is. So let me come over here and press the taxi light key. And sure enough, you'll see that that happens to be key number 34, and it's already selected. Okay? Now let's assume what I want to do is I want to associate a command with that key. I could easily use the DataRef tool right now to go search for them, but X-KeyPad actually has some of this built right into it. It's not quite as robust and as sophisticated as the DataRef tool, but often most of what you're going to want to do you can do right within here. So I can search for taxi, and sure enough I see my various commands. And I can even try it. If I come on down here and pick my lights. Let me just move up here a little bit so we can see the switches and zoom in. Okay. If I try this taxi light toggle, sure enough you can see that the taxi light switch goes on and off. So that's the command I want. I'm just going to copy that, and I'm going to come up and say add a command, and I'm going to paste it. Now if I did this right, I should be able to come over here on this X-K80, and as I press the taxi light key, sure enough, the taxi lights go on and off. It's as simple as that to associate a key to any key on the physical device. And by the way, that's the same thing you're going to do if it were a virtual device, which we'll look at in just a minute. Okay? Now, let's say as an example, I would like to drive the LED beneath that. This is where we get into the concept of logic data refs and logic tests. So the logic data ref is a data ref. It could either be read only or it could be writable, although we're never going to write to a logic data ref, but you know, if it's writable, that's fine. The main thing is it's a data ref that we can read. And that data ref is going to help us drive logic, and the logic is going to be used to either determine what do I want the blue LED to do, what do I want the red LED to do. I can even use it to drive what speech I want, if I actually want speech associated when I operate a particular operation with that key. So we know with the taxi light, we're going to want to look at what data refs actually manipulate the taxi light. So again, I can come in here, I can say search, I can type taxi, and then what I can do is I can actually operate that key, and I can see which ones are operating up in light. Sure enough, I have a couple I can use here. This one here is changing, cockpit electrical, taxi lights on. So is this one down here. Well, I'm going to use the electrical, because I have a feeling that if I actually had the battery shut off, this probably wouldn't be going on and off like this. So I'm going to copy that, and I'm going to come up and I'm going to paste it into this data ref. Okay? So now I've actually got a piece of data that X-KeyPad can look at to determine what to do with the LEDs. Now we're going to come over here to the primary LEDs. And this is where we get into the concept of logic tests. Okay? So here I've got conditions. The blue LED on, the blue LED flashing, the red LED on, and the red LED flashing. And what you're going to find with logic tests is when they're grouped, and here I've got a group. The group is the blue LED. And I have three states for it: off, on, or flashing. Here I've got a group, which is the red LED. And again, I've got three states. It's off, it's on, or it's flashing. And the way the logic tests work is, if I test for the blue LED on, if it is on, I'm not even going to bother coming down and looking at the flashing condition. If the blue LED evaluates to not being on, then I'll come on down and see if the flashing test works. If it evaluates to true, then the blue LED will flash. If neither the on nor the flashing is going to evaluate to true, then guess what? The LED is going to be off and there will be no light underneath it. So in our case, we're going to want to have the blue LED on anytime the taxi light is off. So we know that that taxi light value is going to be a 0 when it's off. And here, it's actually telling you what the comparison is. And just to look at the comparisons, we either can do equal to, less than, greater than, less than or equal to, greater than equal to. We can do an AND operation, which is used for bitwise operations. And by the way, in bitwise operations, there's only a few data refs that explain they actually work with bit positions. Like the autopilot status is one that's like that. We can even do a range, like between values. And we can even force it saying, regardless of what the data ref is, or even if there's no data ref, I can always force it okay to always being true. So in my case, I'm just going to simply use equal because we only have two states, 0 and 1. So we're saying if it equals 0, then it's going to be true and the blue light will be on. And you can see right now I've got the taxi light switches off. It's evaluating to true. And you can see that the key is underneath the taxi light key is blue. It's on. Now we're going to come on down and we're going to say, well, I don't care about anything on the flashing blue LED, so I'll just leave it to an AND operation and give it no value. That's always going to end up evaluating to false. We'll come down here on the red and we'll say equals to 1, which means when the taxi light's on, I want the red LED on, okay? And just to make sure that that's working, if I come over here and I press this key, the taxi light just turned on, and you'll notice that the red LED is underneath is on. Okay, so let's just try something. Let's say, for instance, when the taxi light is not on, maybe what we want is we want the blue LED to flash. So here, I'll set this to an AND, or I can even set it to something like equals a -1, right? That's never going to evaluate to true. And I'll say equals to 0. Now, if this is working right, when I click that key, I should end up with the blue LED flashing. Okay? So that's how logic tests work, okay? And you're going to find that logic tests, they're used all throughout X-KeyPad. You're going to use them to determine what commands you might want to have operating. You're going to use them to turn LEDs on and off. You're going to use them to determine what colors you want underneath virtual device key labels, what labels you want. They're used pretty extensively throughout the system. So another thing we can do here using logic tests is we can actually use it to drive speech. Now right now when I operate this key, you don't really hear anything with regard to anybody announcing anything about what state the taxi light's in. But if we wanted to, we could use X-KeyPads will generate text-to-speech using X-Plane's built-in text-to-speech engine. So to do that, I simply need to come in here and add speech. I'm going to add a logic test for speech, and I'm going to say when the data ref is equal to 0, that indicates that I turned the taxi lights off. I'm going to add another condition. I'll select it down here. If it's equal to 1, that indicates that we turned the taxi lights on. And let's see if that works.
Taxi lights on.
Yep, so I turn the taxi lights on. That's the speech that comes out.
Taxi lights off.
And you can see how that works. Okay, so that gives you kind of an idea of what you can do with data refs and commands, okay, and logic tests. Now let's go in and take a look at how this is going to be a little bit, how we could do this with a virtual device. What I'm going to do right now is go in and create a virtual device for this particular configuration. So I'm going to do it, add a new virtual device layout. I want this to be, we can give it a name. I'm going to use it as preferred unit 0 because we can actually, because a virtual device can display multiple units. I can tell it when the virtual device gets created which unit I would prefer to be the default one. I'm going to let this thing be an XK80, which would give us our typical 80 key layout, but I can change this to anything I want. Like if I want it to be custom, what sizes do I want, that type of thing. Okay, I'm going to leave it as an XK80. I could pick what I want for my default font for this. I can specify whether I want the font to be scaled. This is kind of useful sometimes where if someone were to develop a layout using a 1080p monitor, but then you share it on the X-Plane community, and somebody's trying to run this on a 4K monitor, they may actually want to scale the fonts up so they look a little bit bigger. So you can actually use this to make the fonts come out bigger if somebody is working with a very high resolution monitor with a layout that was done for a lower resolution monitor. And here we can actually control what our update rate is so that we give it the best performance. Okay, and then I'm going to come up and say create this virtual device. And what I'm going to do is just move X-Plane out of the way, and I'm going to pop out my little editor window so that we're just looking at these two things at the same time. Okay? Okay, so we've got our key here for our taxi lights, and if
taxi lights on, taxi lights off.
So I come back over here, notice there's no label in it, and that's because I never bothered to give this key a name. If I give it a name like taxi lights, it's going to go ahead and it's going to put that in there by default. But I could actually make that look a little bit better, okay? I can come over here, and the first thing we're going to do is we're going to come over to the units, and we're going to say that this is a virtual device unit. You'll notice that as soon as I checked off hardware unit, you're going to notice that the XK80 disabled. And that's because I'm now saying that this is a virtual device, and the virtual device will take priority over a hardware device with the same unit number. Okay? And let's come back over here to keys. So let's say I don't really want it to look like that. Maybe I want it to say taxi lights and I want it to be on two separate lines. I can come over here to the key label, okay, and I can add a key label. I could go to lines, and I could say taxi lights. And you'll notice now that they're on two separate lines. I could even come in here and I could do something like that to have a space between them. And you'll notice on the virtual device, as I make it a little bit bigger, the keys are going to get bigger. I don't want to make it too big so that we can't do it. Now, this guy is basically still using the primary
taxi
LEDs.
lights on.
First, I'm going to come in here and get rid of this speech because it's going to be annoying if we have to listen to it all the time. So I'm going to take that away. Notice as I click on now, the speech is gone. And I'm still using the primary LEDs, right? So I'm going to go back in just to show you how this works. I'll change this back over here to a 0. I'll set that to maybe an and. And you can see that I'm using the primary LEDs. Now, the one thing about virtual devices is because it's being displayed on a monitor, we have infinite control over these colors, okay? So what I could do is, let's assume for a moment I want this to be a different color. I could come over here to key colors. And by the way, once I define some key colors, it's going to override those primary LEDs. They're no longer going to, it's not even going to look at this logic over here anymore once I do something over here. So I'm going to add a color, and I'm going to say that when the taxi lights are off, I want maybe this to be, and what I'm going to do is just going to click on that. I'm going to want it to be, I don't know, maybe yellow. Something like that. Okay? And I'm going to add another color here. I'll pick this one. And when they're on, I don't know, maybe I want it to be green. So I can actually take the palette here and I can drag and drop that over here. There we go. Not a very nice yellow, but let's see if we can't make it a little bit brighter here. So you can see how we did that. Now, I can even change the font colors. So as an example, it's a little hard to see these with the white font. I could come over here to the font colors and I could do the same thing. I could say when it's always true, so basically saying I don't care what state the DataRef is, I always want the font color to be black. So you can kind of see the kind of things I can do here. I can even now manipulate the label. Let's come back over here to the label. And now what I'm going to do is I'm going to add another label. So in this case, I'm saying the condition I've got here is always true. I'm now going to set this to say when it is equal to 0, I'll say taxi lights off. And here I'll say when it's equal to, what did I say? I said that's equal to 0. When it's equal to 1, I'll say taxi lights on. So now you can see as I flip the lights back and forth, I'm also able to change the label. So you can kind of see how you can do this. And in another tutorial, we're going to walk you through many more complicated things you can do with these labels. I mean, you can break them up into line segments, you can change the fonts on them, you can embed numeric data in them. There's quite a bit you can do with the keys on these virtual devices. But I wanted to show you is the basic capabilities of what you could do in here. Now, one more thing we could do with virtual devices. It's pretty easy to copy and move keys around. Say, for instance, I decided I don't want this key here, I want it someplace else. I could come up here, and by the way, you could even use a virtual device to create configurations for a physical device. Perfectly fine. All you have to do is go back over here to the units and just mark it now, unmark it as mark it as a hardware device, and the hardware device will start working again. So sometimes it's helpful just to get your layout done before you actually label your physical device. I can come up here, I can go to edit mode, and I could say go to drag a drop, and I'm going to do a move. In this case, I can now move this key from here over to here. Okay? I can even do things like replicate that key. So I'm going to shut off drag and drop mode. I'm going to go to copy paste mode. I'm going to check it. I'm going to copy it. And then I'm going to come and I'm going to paste it there. Okay? And then I can just take it out of copy paste mode. So if you don't like your layout, it's really easy with virtual devices to change the layout of them. And again, if you're working on a hardware device, you can use the virtual device as kind of your editor, move all your keys around, and then go through and take all the keycaps off your physical device and move them to where your new layout says that they're at. Okay? And when you're done with your changes, all you have to do is do a save. Okay? And that saves it. Next time I load that plane, this is going to come up. And if you had any virtual devices created here on the Virtual Devices tab, as soon as that plane's loaded, the virtual device window will come up, and it'll come up wherever you placed it at. So if you put it over on another monitor, it'll come up on that monitor. So that's kind of an overview of how you go through and basically use the DataRef tool. What's the difference between hardware devices and virtual devices? How to use commands, how to use DataRefs, how to define a basic key. And again, this is all very basic introductory tutorial. The other tutorials will take you into a much greater depth with a lot of examples showing how to do pretty complicated things, okay? Thank you very much for watching, and I hope you enjoy X-KeyPad.